Number 8. Draw a Lewis structure for each of the following molecules and then use the VSEPR theory to predict the molecular geometry of each. All right, so here's my Lewis structure for what is that? Sulfur dichloride. All right, we can see that we have the bonded chlorines are being bent down by these lone pairs on sulfur, so it's bent. And yes, geometry just means shape, so we're referring to these shapes here over on the left. Pi3, phosphorus triiodide. Spreading out, so it's going to be trigonal, but we have this lone pair of electrons on the phosphorus are going to orient those bonds down in more of a pyramidal shape, so we have trigonal pyramidal. C, you have 2 chlorines, 1 oxygen. The oxygen is going to be central, bonded to these chlorines, but again, just like over here in A, we have lone pairs of electrons on the central oxygen driving the angle of the bonded chlorines down, making a bent shape. D, we're going to have the central nitrogen, and we have 2 hydrogens bonded and 1 chlorine. And no, it does not matter in which order you draw these. Okay, it's a 3-dimensional orientation. It's going to allow your drawing to be accurate. But we see that we have 3 bonded atoms and 1 lone pair. And so the lone pair is going to repel each of the electrons in each of these bonds and drive the bond angle down, resulting in that trigonal pyramidal. Again, we have AB3 plus an electron. So it's not trigonal planar. We have this E right here that we have to account for that's driving these electrons down into this trigonal pyramidal shape. So for this bad boy right here, E, this is a big old scary mess, but we have the central silicon, and we have chlorine, 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 bromine all around it. All right, we have single bonds all around. Because we have no lone pair around here to drive any of these bond angles down anywhere, we're simply going to have an AB4 format. That's going to give us tetrahedral. And lastly, we have ONCl, so we're going to have a central nitrogen since it's the least electronegative, right? Compared to these two, least electronegative. So I have nitrogen in the middle. We have its lone pair. We have a double bond to oxygen, a single bond to chlorine. Everybody's happy. But these bonds are being driven down in angle by this lone pair. This lone pair of electrons is electrostatically repelling the electrons present in each of these bonds, pushing them down, pushing them away from that linear shape that they might otherwise inhabit if not for that lone pair.